A capacitor of 2 mu F is charged as shown in the diagram. This is one of the capacitor. This capacitor is 2 mu F and it is charged here. When the switch S is turned to position 2, that means when the switch is turned to the position 2, the percentage of its stored energy dissipated is we need to find here. How much percentage of the stored energy is dissipated we need to find here. So we know here that when switch when this switch S is terminal 1 are connected, when it is connected to the 1, then the 2 mu F capacitor charges up to the potential difference V. The potential energy stored in this capacitor is given by, that is U1, we can write it as Ui is equal to 1 by 2 CV square. That means, which implies V square for a capacitor of 2 mu F here. Okay, this is the simplifies here. And then when switch S and terminal 2 are connected, the 8 mu F capacitor also charges up. During this process, the current flows through the wire, causing some energy to be dissipated as heat. The energy loss, denoted as a delta U, is calculated using the formula, that is a delta U is equal to 1 by 2 times C1 into C2 divided by C1 plus C2 into V1 plus V2 whole square, where C1 is equal to 2 mu F and C2 is equal to 8 mu F. V1 is V and V2 is 0. This implies to we get answer, that is a 4 by 5 V square. Then this percentage of energy dissipated is then calculated as, that is delta U divided by Ui into 100. Then we get the answer 4 by 5 V square divided by V square into 100. If I cancel these two, then 4 by 5 is nothing but the 0.8. 0.8 into 100, which is nothing but 80%. Then option D is the right answer.